All right, today what we're doing is looking at what's known as exact values. So the exact values for sine, cos, and tan as well. So let's refer back to the unit circle. So here we've got a couple of unit circles and drawn out. And so both this here, radius of 1, and I've drawn a couple of triangles here, and so let's look at the one on the left. And so I've drawn this triangle purposely so that that length there is 0.5. All right, and then that's 1, and so then there'd be a length here. And the other one I've drawn purposely again so that up here the y value of that point is 0.5. So I could actually put in some, for this point P, it's 0.5 and something. And this point over here, this point P here is something and 0.5. So if we take out get rid of that, those circles. So if I take this triangle here out, for example, and I take that triangle, put it here like so. That's a bit ugly, but anyway, that's 1, that's 0.5, and then what's that length there? If we use Pythagoras, and I'll call that length, I'll call that A, okay? So we know that A squared plus 0.5 squared is equal to 1 squared. Now I'm going to write I'm going to write 0.5 as a half. So A squared plus a quarter equals 1. Take a quarter from both sides. Forgot my squared. A squared would be 1 minus a, so take a quarter. Take a quarter. It would be 3/4. And so A then, side length A, would be the square root of 3/4, which we could write as the square root of 3/2. Now, they would be what we would call exact values. All right, so rather than writing it as 0.5, writing it as a half, and 3/2. And so this length here is root 3/2. This length here, 0.5, is a half. Excuse me. Now, this angle here, so this rectangle, this triangle, and this triangle, hopefully you'll be able to tell me, because this is a half here, that they're the same triangle. They're just at different orientations. So that means that this length here would be the root 3/2. And this angle there was the same as that one. And I want to change my pen color. This angle up here is this little one down there. All right. So if we knew what those angles were, then we could figure out what some exact values. Now, as it turns out, those particular angles, and let me change my color back, are not any random angles, but let me draw there. All right, so I'm going to draw the little angle there. So that one's the half. And so we're looking at this angle in here. And so that point there would be root 3/2, and 1/2. And remembering from the definition, let me get rid of those circle things. By definition, this is our cos of theta, and this is our sine of theta. Question is, what is theta? Well, it turns out, and there's a thing in your book that kind of that shows you this in your textbook, but it turns out that for these particular values of cos theta being √3/2 and sine theta being 1/2, it turns out that in this case situation, our theta is 30 degrees. And of course, pi on 6 radian for the radian version. All right, so then if we looked at that one there, for example, and I'll draw it down here. Yeah, it always does that when you start a new page. So that's this one. So this time that's 1/2 there. So our point now is 1/2 and √3/2. Let me get rid of those circly things. And so now we're looking at this angle, and I'll use a different symbol, alpha. Excuse me. And so that's cos of alpha, and that's sine of alpha. But in this situation, because we know that's 90 degrees, and this one up here is the theta from before, which was 30 degrees. So then our alpha would be 60 degrees, or pi on 3 in the radians. And so we've got some exact values for sine and cos of 60 degrees. So sine 60 degrees, the exact value is √3/2, and cos of 60 degrees, the exact value is 1/2. Also, there is some for 45 degrees as well, but I won't go into those. All right, so let's have a look at this GeoGebra. All right, so here's our unit circle, and it's got specific ones on it. So for 0 degrees, of course, if you want 0 degrees, 90 degrees, 180, 270, or 360, you need to again look at those points. So we've got exact values there for 0 degrees. Cos of 0 is 1 and sine is 0. All right, these. And so the 30 degrees, which is our pi on 6. All right, so those numbers that we've just worked out, I've just shown you. If I then keep going around further, the pi on 4 one, it's √2/2. I'm not going to show you that by using Pythagoras how that works out to be the case, but if you're really desperate to know that, you can talk to me and I'll show you. And then of course, when we come up here to our 60 degrees, the values are the same but swapped. So we've still got the 1/2 and the √3/2 like we did for 30, but they're swapped around, okay? It's because that triangle and that triangle are the same triangle, so this up the top here is our 60 degrees, so it's just been, our triangle's been rotated around. And there we get to that. All right, so there is then angles in the other quadrants that are similar. So like this is 60 degrees here, this, or pi on 3, and if I go here and I go to 120 degrees, which is all the way around to there, from the positive x-axis all the way around, you'll notice that it highlights this triangle here. And why does it highlight this triangle? Well, these two triangles are the same. It's just been reflected and flipped across. All right, so this angle between the x-axis and our radius line, that one there, well, if you do 180 minus 120, you get 60, which is the same as that angle in here, 60. And so the numbers, the values, are the same. However, you'll notice that the cos one is negative because in the x we're in the negative direction. So there's also exact values for other in the other quadrants. So you could come up with a big long list of them, and this is what that big long list of them would look like. All right, but that's pretty hard to remember all that big long list. So we need a better way of doing things than remembering that big long list, and there is a better way of doing things than remembering that big long list. And I will show you how we can do that other than with the big long list. All right, so for example, let's have a look at an example. Let's find the cos of, let's say, 210 degrees. So what we can do is we can have a look here and say, okay, here's our unit circle. And I always draw a unit circle. And that would be my recommendation. Although there's always people who don't want to. But for me, it makes things easy to see. All right, so 210 degrees is more than 180, so but less than 270, so it's here somewhere. All right, that's 270 degrees. 270, what am I talking about? We're not after 270, we're after 210. That's 210 degrees. Now, the key angle, the key thing that we're looking for here is what is given the term the reference angle. Now, the reference angle is the one between the line and the x-axis, always the x-axis, okay? So if that was 180 all the way around to there, and this is 210 all the way around to there, the difference between them, which I'll calculate over here, 210 minus 180 is 30 degrees. Now that's there is 30 degrees, and that is then what we would call our reference angle. And so we could come back to our first quadrant, and I'll do that here like so, and we've got an angle of 30 degrees here, and we're after the cos of 210. So the cos of 210 is related to the cos of 30. All right, and the cos of 30, because I remember, is root 3 on 2. People are going, how can you remember that? How can you remember that? Well, I can remember that by doing this. Let's say, all right, here's a triangle. This little angle here is my 30 degrees. That's my right angle, and that's 60. My hypotenuse is 2. The long side is root 3, and the short side is 1. And then I'll go, okay, so the cos of 30 degrees from that, and cos is adjacent over hypotenuse, and the cos of 30 then is the adjacent over the hypotenuse, root 3 over 2. So you can use that triangle, and you can use it for angles to do with 60 as well. Anyway, so I know that's root 3. So let me change back to my blue pen. So the cos of 210, what do we know about it? Well, we know it's related to the cos of 30, and the cos of 30 is root 3 on 2. The other thing we need to look at is which quadrant it's in. And so 210 is in over here, and that is the third quadrant. And in the third quadrant, let me change my pen color. I'm going to go to red. And remember, all students talk crazy. So these are the ones that are positive. All are positive. Sine is positive. Tan is positive. And cos is positive. So we're in the third quadrant, and tan's the only one that is positive. So if tan is the only one that's positive, that means cos is negative in the third quadrant. So the cos of 210 degrees is negative root 3 on 2. So rather than remembering that whole big long list of stuff, we can work it out using this triangle, or the other triangle that I'll show you for the 45 degrees one, and knowing that symmetry stuff. All right, and so on that GeoGebra thing, what were we looking at? 210, which is here. All right, and so there it is, all the way around there. So that angle there, the reference angle. So these are our reference angles here between the x-axis and the line, and these are our reference triangles, if you like, over here. All right, let's have a look at then another example, and I'm going to say let's find the sine of, let's go 5 pi on 4. All right, so unit circle, 5 pi on 4, 5 pi on 4, 5 pi on 4, 5 quarters of pi. So 5 quarters is 1 1/4. So remember, it's pi all the way to here. It's pi on 2. This is 3 pi on 2 here. So the one we're looking for is all the way around there. That's 5 pi on 4. So our reference angle is this angle here between the x-axis and the line. And if it's 5 pi on 4, 1 1/4 pi's, this angle here is pi on 4. Okay. So the triangle that I use, let's go back here, the triangle that you can use for 45, or pi on 4, is this one here, and that's 2 root 2 root 2. And so the sine of 5 pi on 4, so we're down here in the third quadrant. So in the third quadrant, sine is negative, and it has a value of the opposite over the hypotenuse, root 2 on 2. So that's how we would do that. Now, Sometimes you see are written for the sines and the coses, you see them written as 1 on root 2. Now, if this 1 on root 2, if I rationalise the denominator, I get 1 times root 2. Yes, rationalise the root 2 times root 2 is root 4, which is root 2 on 2. All right, so 1 on root 2 and 2 on root 2 on 2 are equivalent. However, you are expected in VCAR exams to use this form, the rationalised denominator form. However, it's handy to know that these things are the same. All right. Okay, I've waffled on for quite some time here. How long have I waffled on for? 20 minutes. All right. Let's go one more example because we haven't done a tan one yet. Haven't done a tan one. Find a tan of anything. So let's do a tan one. So let's find the tan of, let's say, and I'm going to do this in pies. Let's go 11 pi on 6. Tan of 11 pi on 6. So let's have a look. 11 pi on 6, where would it be? Okay, so remember that's pi on 2. That's pi. Now, in terms of pi on 6, that would be 6 pi's on 6, wouldn't it? And then all the way around, if we keep coming around, so that's 3 pi on 2, and then we get around, so we start at 0 this way, and then we head that way, and then we come in, and that's 2 pi. Now, 2 pi's would be 12 pi on 6, wouldn't it? So 11 pi's on 6 would be not quite 12 pi's on 6. So that would be to here. All this way around here would be 11 pi on 6. Now our reference angle, and remember as I was saying, the reference angle is always between the line and the x-axis. So that's this one here. Well, if that's 11 pi's on 6 to there, and a full circle is 12 pi's on 6, then that angle in there is 1 pi on 6. All right, so what have we got to do? We've got to have a look, and we've got to go, okay, so when we remember that all students talk crazy, that it's cos that's positive in that fourth quadrant. We're interested in tan 11 pi on 6 is in our fourth quadrant. So our value for tan is going to be a negative value, and it's going to be related to the tan of pi on 6. All right, so this is where I bring out my triangle again. Here, triangle here, the big angle is 60 degrees, which is pi on 3. Whoa, 3, not 2. The little angle here is 30 degrees, which is pi on 6. Hypotenuse is 2, the long side is root 3, the short side is 1. And, excuse me. And we are after the tan. Pi on 6, tan is the opposite over the adjacent. So the opposite, which is 1, over the adjacent, which is root 3. Excuse me. And again, this is not in rationalised form, so we need to rationalise. And so that becomes negative of 1 times root 3 is root 3. Root 3 times root 3 is root 9, which is root 3 on 3. All right, so there's exact values. I will, for your reference, put, no, not that. Well, that is up on the Physics with Synno page, this particular thing. But I will also, for your reference, put this exact value sheet. Personally, I don't remember any of that stuff there. Personally, do not remember any of it. All right, so personally, I always go back to this, what I've said here. So all I've got to remember then is I've just got to remember these two triangles, which are pretty simple to remember. And then also remember that use this reference angle. Remember which is positive, all, sine is, tan is, cos is. That's all I've got to remember, and then I can work out every single one. All right. And this process that I've been doing here with this, when we get to solving trig equations, we use this process here to solve the trig equations. So that can, instead of us remembering a whole bunch of different stuff, we can just use those patterns for us to then work out a whole heap of stuff when we need to. All right. As always, have fun, and if you need help, get back to me.